Talked about inductive reasoning already, and inductive reasoning is to make conclusions based on observations. And we're looking for patterns. Okay. Unlike inductive reasoning, which is based on observations and patterns, deductive reasoning is reasoning that uses facts, rules, definitions, properties, and then you reach a conclusion. Okay, so I don't know if you remember when I was talking about inductive reasoning and I said if you notice that I had a coffee cup every day, you might induce that I like coffee. But you don't know for sure that there's coffee in the mug, right? It could be tea, it could be water, it could be anything. If you were to try to use deductive reasoning to come up with a conclusion based on the fact that I'm bringing a coffee mug to work every day, you would look inside the mug and know for a fact that there's coffee in there every day, and then you could deduce that I like coffee. Does that make sense? So deduction is fact-based. You have to know for sure. You can't just make kind of assumptions and then come to conclusions. You can't just look for patterns. So when we look at these, every time Katie has worn her favorite socks to a softball game, she's gotten at least one hit. Katie is wearing her favorite socks to the game tonight, so she concludes she will get at least one hit. Is that induction or deduction? Induction, right? Because it's not a fact that her favorite socks are causing her to be able to hit the ball, right? It's just a pattern that she has seen. Okay. If John is making his car insurance payment, he will be assessed a late fee of $50. Or if he's late making his car insurance payment, he will be assessed a late fee of $50. John's payment is late this month, so he concludes he will be assessed a late fee of $50. Deduction, right? Because it's based on fact. The fact is, if you pay late, they charge you a fee. So induction is observations and patterns. Deduction is like cold hard facts. All of the signature items on the restaurant's menu are shown noted with a special symbol. Kevin orders a menu item that has this symbol next to it, so he concludes that the menu item that he has ordered is a signature item. Yeah. And none of the students who ride Rawls' bus own a car. Ebony rides a bus to school, so Rawl concludes that she doesn't own a car. It would be induction. Unless we absolutely know for a fact that Ebony doesn't own a car. Or we absolutely know for a fact that nobody that rides the bus, for sure, nobody owns a car. If we can say that we can disprove a conclusion with a counterexample, then it's not a valid method of proving a conjecture. So it's not logically correct, okay? So to prove a conjecture, we have to use valid arguments. So validity, if you're valid, you're logically correct, you are fact-based, and you cannot be disproved by a counterexample. Like, if your argument is valid, I can't say, oh yeah, well, there was tea in my mug yesterday, so sorry, you're wrong. I don't drink coffee every day. That kind of thing. Okay. The law of detachment is one way to use deduction. It's a valid deductive reasoning. Okay, and we're using the conditional statements, if P then Q. Okay, so what we have is if we have the statement if P then Q, and that is true, and P is true, then Q is also true. Okay, so for example, okay, if my car is out of gas, then it won't start. True?
True.
Okay, so the whole statement is true. Okay, now let's say my car is out of gas. It's true. Let's just say I didn't put gas in my car, so it is out of gas. That part is true. Because this first part is true, it makes this part true. Okay. If my car was not out of gas, and this would be false, then Q would also be false. So the statement in itself is true. If your car is out of gas, you won't be able to start it. So then if that first part is true, the car is out of gas, it forces that the second part is also true. If that first part is false, then it forces that the second part is also false.
If it had or, it's going to be.
Well, we're doing if then, so there's not really an or there. It's going straight. If this, then that happens.
Okay.
And then it kind of follows that if not this, then that doesn't happen. Does that make sense? Okay. So if we have some statements and we want to see if our conclusions are valid based on the law of detachment, okay, it says if two angles form a linear pair, then their non-common sides are opposite rays. So this is my conditional statement. If two angles form a linear pair, well, if we look at that, we have a linear pair, kind of looks like that. Then their non-common sides, those are these sides here, are opposite rays. Is this true? Yeah. Okay. Then we say angle AED and angle AEB form a linear pair. So if I draw that, oh, I typed that wrong. Sorry, that should be DEB. Okay. Oh, AED and, hold on. Maybe I didn't type it wrong. Maybe I'm labeling it wrong. I'm doing something wrong. ED and E, that's E, that's D, that's B, that's A. Yes, see, I was labeling it wrong. Okay. So AED and AEB form a linear pair. The conclusion is ED and EB are opposite rays. Two angles form a linear pair, that's true. Therefore, my conclusion, their non-common sides are opposite rays. That's going to also be true, so this is valid. Does that make sense? If Micah goes to the beach, she will wear sunscreen. Okay, so we're going to say that this is true. This whole given statement is true. Micah is wearing sunscreen. This part's the Q, and this part is the P. Now, our law of detachment says that if P is true, it makes Q true. It doesn't go backwards. Q being true does not force P to be true. It's only P being true that can force Q to be true. So this is invalid. Okay? And here's, I can do a counterexample.
Why?
Because P became my conclusion.
And is that the end?
Yeah, so in order for it to be logically valid through the law of detachment, it has to stay in order. The whole statement has to be true. This first part has to be told to be true, and then this is my conclusion. They flipped it. Do you see that? The conclusion is she's at the beach, but that's not my conclusion from my original statement. And we can easily disprove this counterexample. She's at the pool. Right? She could still be wearing sunscreen, but that doesn't mean, just because she's wearing sunscreen does not mean she's at the beach.
So you gotta think outside
Yeah.
into like real world.
Yes,
situation.
exactly. So being at the beach means, yes, she'll wear sunscreen. But just because she's wearing sunscreen doesn't mean she's at the beach. It doesn't go backwards, it only goes forwards. Does that make sense?
Yeah.
Okay. All right, maybe she's not at the pool. Maybe she's in a tanning booth. You know, who knows? Like, but there's lots of places that she could be wearing sunscreen. Okay. If we're given, if 3 points are non-collinear, oops, that's a plane, not a plan. And that's a they, not a thee. Wow, I can't type. Okay. If 3 points are non-collinear, they determine a plane. Okay. Points A, B, and C lie in plane G. My conclusion, points A, B, and C are non-collinear.
It's a plane.
This is P, this is Q, right? My conclusion, just because they lie, it's not going to be true. Because remember they flipped it again. This is Q here, and this is P here. My conclusion can't be P. My conclusion has to be Q. So your conclusion has to be the they part in order for it to be logically valid. So this is invalid. Again, these are both, let me get how about orange? Orange is good. These are both flipped. And that makes it so that it's no longer valid. And again, we can come up with a counterexample. If I have a plane and my plane is G, and look at that, points A, B, and C can all be on the same line. Just because they're in the plane doesn't make them non-collinear. You have to be non-collinear to determine a plane.
I thought non-collinear meant
Not on a straight line.
not on the same line.
Right, and this is what I'm saying. I can easily provide a counterexample
Oh,
that they could be on the same line. And it's because, again, it's because they flipped that. The conclusion, I could write, okay, in order to be logically valid through the law of detachment, the conclusion has to be the then part. You can't have the conclusion be the if part.
So if say it was, so then
It
should have said the conclusion points A, B, and C are non-collinear.
well, it should have been,
It should have been where the Q is at, right?
yeah, this part should have said points A, B, and C are non-collinear, and then this part should have been points A, B, and C lie in plane G. And
Okay,
then it
that's
would have
what
been, yeah, if you flipped these two statements, if you've just flipped them, then it would be valid.
Okay.
Does that help?
Yeah.
Okay. All right, we can do this with Venn diagrams also, if you don't remember the order. Okay, so we can have, if a primate is an ape, then it does not have a tail. Okay. Coco is a primate who does not have a tail. Okay, so what I can do is I can draw a box that represents primates. Okay. and I can have a box that represents 8, or a circle that represents apes, and I can have another circle that represents primates with tails. Okay. Now, if I say for sure that if you're an ape, you don't have a tail, so these two circles don't overlap. But if I say Coco doesn't have a tail, is she here or is she here?
Yeah.
We don't know. We don't have enough information, right? Are there other primates that don't have tails? Yes. Chimpanzees, orangutans, bonobos. I mean, there's a bunch of primates that don't. Okay, ready? People. We're primates without tails. So there's a bunch of primates that don't have tails. So the fact that she doesn't have a tail does not make her an ape. We wouldn't know where to put her. And again, if we look at this, this is the Q and this is the P, so it's flipped backwards. So it's invalid. And then as a counterexample, I could say, well, Coco's a chimpanzee. That doesn't, she's not an ape. Or she's a person. You know, Coco could be, Coco's my best friend. What are you talking about? Like, she's a person. She doesn't have a tail. Doesn't make her an ape, right? Okay. If a figure is a square, then it is a polygon. So we have polygons. And inside the polygons, we have squares. Right? If a figure is a square, then it is a polygon. Well, if I'm a square, I'm inside the square circle, but the square circle is inside the polygon box. So if I say figure A is a square, then it is a polygon. This is a valid conclusion. And again, that's because this was P and this is Q, and so they came in the correct order. Law of syllogism, which is another valid deductive reasoning.
What are the root words for that, for syllogism?
So, okay, so the law of syllogism, it says, it's kind of like a compound statement. So, if I have if P then Q, and then I have if Q then R, and they're both true, okay, then P to R is a true statement. Okay, and I'm going to give you kind of an example. So like, if okay, if you get a job, then you will earn money. This is P, this is Q. Okay. If you earn money, then you'll buy a car. Earn money was Q, so this is R. Okay, so if you get a job, then you will earn money. True. If you earn money, then you will buy a car. True. So I could condense that to if you get a job, then you will buy a car. Basically, we take out the middleman, the Q, the part that matches in both. We can take that out and take the original first hypothesis and the final conclusion and just push them together. kind of like 4 quarter, or a dollar is 4 quarters is 10 dimes, so a dollar is 10 dimes kind of thing. Like you can take that middle piece out. Okay, so if we have, we're going to assume both of these are true. Okay, so if you like musicals, then you enjoy theater productions. If you are an actor, then you enjoy theater productions. Did I type that right? So we have P, Q, and R. Okay, we're going to determine which of these is true. Okay, what we have is P to Q and R to Q. Do you see how these don't match?
Wait, how come that way? Oh, because it's R.
Yeah, so what we're looking for, in order for this to be valid, what we want is P to Q, Q to R. And then we can take out these and just go P to R. Does that make sense? What we have right now is P to Q, R to Q. So because of that, there is no valid conclusion. Because we don't have a middle guy that can take out, so that you can see how this kind of makes a Z. If we match these, we can get rid of him and just sort of go around it. And it goes straight from P to R. But here we have PQ, RQ. That doesn't connect.
So if Q was...
If these two were flipped, and it said if you enjoy theater productions, then you are an actor, and if that was still true, then it would work. But you have to have P, Q, Q, R, and again, that's because we can cross these out, and that makes the connection to go from P straight to R. We take out the middleman.
So how about with that first example, like you said, if you get a job,
Then you earn money. If you earn money, then you'll buy a car. Here's P to Q. That's P to Q. And then we have Q to R, Q to R. And then here we took out Q, and it just went straight from P to R. Okay, let's try another one. Okay, here's P, Q. If you are tired, then you will not do well on the test, R. Okay, so we can take out Q, and we can go straight from P to R. So if you do not get enough sleep, then you will not do well on the test. So B. So we've got P to Q and Q to R, and we take that out and just go straight from P to R. So if we do not get enough sleep, you will not do well on the test. This is valid. These are not. Okay. We're gonna, so we'll start the first one. If the sum of the measures of two angles is 180, then the angles are supplementary. Okay, here's P, here's Q, and then we have this statement, that's P repeated. The sum of the angles is 180. So angle A and angle B is 180. So our conclusion is A and B are supplementary. It's valid. And that's because this is the Q. So it went P, Q, P, Q. Okay. So it's valid. So let's try this one. We have if the sum of the measures of two angles is 90, then the angles are complementary. So this is P, Q. I have the measure of angle ABC is 45, and the measure of angle DEF is 48. Yeah, it's invalid. And that's because the sum was not equal to 90. So P became false. And as soon as P is false, then Q is false. So a false P yields a false Q. which equals invalid. Does that make sense? Okay. All right, why don't you guys try number 3? What do you think? I'll give you a hint. What does this mean?
Straight line saying yes is true.
Right, it means 180. So this becomes valid. Okay. All right, so we're going to draw a valid conclusion from the given statements if possible. We're going to state whether we're going to using the law of detachment or the law of syllogism. Now remember, the law of detachment is just one P and Q. And law of syllogism goes P, Q, Q, R to PR. Okay, so that's really the only difference between them. So this is just P to Q, and this is P to Q, Q to R, and that gives me P to R. Okay. So if no valid conclusions can be drawn, we're going to say no valid conclusion, and then you say why. Okay. So if you are 16 years old, then you can apply for a driver's license. Nate is 16 years old. What's my conclusion? Well, here's P. Here's Q. Is this a P or a Q statement? P. So that means we can get Q. So my conclusion is valid, and my conclusion is Nate will apply for driver's license. Okay. The midpoint of a segment the midpoint divides a segment into 2 congruent segments. If 2 segments are congruent, then their measures are equal. Okay, this isn't exactly written in the if-then form, but I could say if you have a midpoint, then you divide into 2 congruent segments, so I can make that into an if-then statement. Does that make sense? So that makes the midpoint part my P, the dividing into 2 congruent segments my Q. If 2 segments are congruent, then their measures are equal, R. M is the midpoint of AB. This is a P, because I have a midpoint. But what does that mean is going to happen next? If I have a midpoint, I'm going to do what?
Midpoint divides section
Into 2 congruent segments, right? So I'm going to have A, M is congruent to MB. That's going to be my Q.
Your R is the...
So my conclusion, my measures are equal. Okay. So the fact that I had a midpoint gave me the 2 congruent segments. And the fact that I had the 2 congruent segments gave me equal measures.
So invalid?
It's valid. These were both valid. Okay. Trying to think of a real quick invalid. Well, you know what? I bet you we have some in the homework. That's okay. These are actually right. Why don't we look at these on the page 21 again and see if we can come up with a valid conclusion? Oh, darn! I didn't type well again. It's axiom, not AIM. I don't even know what an AIM is. Okay. Postulates are also known as axioms, and they are statements that are accepted as true without proof.
What is statement? What is that?
Oh, so that's too hard to see, huh? Okay, hold on. Okay, so postulates are statements that are accepted as true without proof. And we've already talked about some postulates. We had the ideas about points, lines, and planes, and how they go on forever. I didn't prove that to you, but you accept it as true. Okay, so we have other postulates. Through any 2 points, there's exactly one line. Okay, if I put a point here and I put a point here, and I start a line, now granted my points are super fat, so you could maybe fit another line in there because I made super fat points, but in reality the line is the same width as the points. So can there be any other line that goes through these 2 points? No, there's only going to be one line that goes through these 2 points. Any other line I draw is not going to hit both points. Okay. Through any 3 non-collinear points, there's exactly one plane. So if I draw 3 non-collinear points, and I make a plane, there's only going to be one plane. If I draw some other plane, it won't hit all 3 points. There's only going to be that one piece of paper that will hit all 3 points.
It's like that one point's over the other.
Yeah, so like if I have my 3 points were on this piece of paper, let's just say my points are this picture, this question, and that bit right there. Okay. If I do any other plane than this, any other sheet of paper, and it comes in any other alignment, it won't hit all 3 of those zones. So that has to be only one plane through any 3 non-collinear points. A line contains at least a plane. Sorry, my typos are getting bad. Plane, not a line, a plane, contains at least 3 non-collinear points. Okay. Oh, that's what I did. You'll have to forgive me and my bad typing. The line is okay, it's the plane. This part's wrong. There we go. Now it's fixed. A line contains at least, no, it's not fixed. Come on. 2, not thu. Okay. A line contains at least 2 points. So if I have a line, right, there are going to be at least 2 points on it. If 2 points is what it takes to create a line, then the line has to have at least 2 points. So these two kind of go together. They're sort of backwards of each other. And then we have a plane contains at least 3 non-collinear points. So if I have some plane, it has at least 3 points that are non-collinear. Because it takes 3 non-collinear points to make a plane, so then a plane has to have at least 3 non-collinear points. Again, they're backwards of each other. If 2 points lie in a plane, then the entire line containing those points also lies in that plane. So I have a plane. I have 2 points. And I have the line, ooh, that's not pretty. I have the line going through those points. If the points are lying flat on this piece of paper, if I draw two dots on this piece of paper and then I draw a line connecting them, it's also on the piece of paper, right? So it makes sense.
Right.
Okay. Then we have if two lines intersect, their intersection is exactly 1 point, right here. And if two planes intersect, their intersection is a line. So let's see if I can draw this. I'm going to draw it over here. Okay, and then they're intersecting through here. Let's change that color to red. Okay, so if they're intersecting, they're cutting through each other. So I have this piece of paper and this piece of paper, and they cut into each other, and they're going through each other, and you can see how that makes a line where the two meet.
How do you find out the points though?
The points on the intersections of the plane, they would have to be labeled at some point, because this is an infinite line and two infinite planes, so they'd have to give you some sort of a frame of reference. I wouldn't be able to just look at this picture and say, oh, this is point whatever.